to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Iris Durmishi. I'm a CNCF ambassador and a senior observability engineer at Miro, and I'll be your host today. Every week, we bring new presenters to showcase how to work with cloud native technologies. They will build things, they will break things, hopefully, and they will answer your questions. In today's session, I'm thrilled to introduce Mariam and Charles Edward, who will be presenting on exploring the power of CEL in Kyverno. Don't forget, this is an official CNCF live stream, and as such, it is subject to the CNCF Code of Conduct. Basically, please be respectful to each other. Do not post things on the chat that could offend other presenters or people that are also watching. At the same time, I'll be looking at the comments, so please don't hesitate to leave yours, and we will answer them in the end. I'm leaving the stage to our two presenters to introduce themselves.
Mariam?
Yeah, okay. Hi, everyone. Thanks for joining us today. I am Mariam Fahmi. I work as a software engineer at Nirmata. I'm also a Kyverno maintainer. So my journey with Kyverno started as an LFX mentee, where I had the opportunity to learn a lot of things, and I enjoyed it so much so that I kept contributing to Kyverno even after the mentorship has ended, and eventually I became a Kyverno maintainer.
Okay, I'm Charles-Edouard Bretéché. I'm also working at Nirmata as a software engineer. I'm also a Kyverno maintainer. I've been a maintainer for a bit more than 2 years now, I think. And yeah, I'm working with Mariam on Kyverno, and that's what we're going to talk about today.
It's a pleasure to have you here. And before I give the stage to you two, I just want to say that in the end, we're going to have 5 to 10 minutes so we could answer the questions that are in the chat. So don't hesitate to put them there. And now I'll disappear and leave the stage to you two.
Okay, so today we are going to introduce what Kyverno is and how it works, and then we will take a quick look at how the different types of rules that Kyverno supports, and finally we will dive deep into the new policy types and the exciting features that are coming in the new release. With that said, let's get started. So first of all, what is Kyverno? So to put it simply, Kyverno is a policy engine for Kubernetes, which means that, like, for example, if you have a namespace and you want to make sure that any pod that is created in that namespace must have a specific label. So for this use case, you can write a Kyverno policy that matches pods in that namespace, and then you can write the validation logic where it validates that a specific label exists in that pod. So how this works internally. So when the user creates a pod, an API request is sent to the API server in Kubernetes, of course, and this API request goes through multiple stages. The first stage is authentication and authorization, where the API server validates who sent the request and whether they have the permissions to create the pods. And after this stage ends, the API request goes to the second stage, which is the admission webhook. And this is where Kyverno comes in. So in that case, the API request will be forwarded to the Kyverno server, and it is the responsibility of Kyverno to fetch all the policies in the cluster that match the incoming request from the API request. So in our example, it is the pods. And then after fetching all the policies that match pods, the Kyverno engine will apply those policies to the pod, and finally it will either reject the API request or it will allow it, depending on whether the resource violates the policy or not. So this is just a quick overview of how Kyverno works internally, and we also have two main components as a part of Kyverno, as a part of the Kyverno, which is the reports controller. And the reports controller is responsible for generating policy reports as a result of applying the policies to the resources. So at the end, you can view the results of applying the policies in reports. And we also have the policy reporter dashboard, where you can view all the reports that are generated. And we also have the cleanup controller, and the cleanup controller is responsible for the cleanup policies. So this is a policy type where you can define the resources, unused resources, and the cleanup controller will remove these unused resources on behalf of you. Let's take a quick look at how can we write a Kyverno policy. So in general, we have only one policy that we have only one policy type, and in this policy type we can define multiple rules. We have different types of rules. So for example, each rule can define. In each rule, we need to specify two things. The first thing is the match block, where you specify which resources this policy will be applied to. And there is an optional exclude block where you can exclude specific resources. For example, you can write a Kyverno policy that match pods and excluding the pods from a specific namespace. This is one use case. And the second important thing is to specify the type of the rule. So Kyverno have different types of rules. You can validate resources, you can mutate resources, you can also generate new resources based on another resource. For example, you might have a use case where you need to generate a network policy for each new namespace. You can also verify images. So Kubernetes is all about containers, and you have to make sure that images are signed. So for this use case, you can use verify image rules to verify the signature of the images. Yeah, and that's it. So we can have a quick look at some of the examples of the current behavior. So in case you need to validate resource, you can write a Kyverno policy of type cluster policy. And under the spec field, we have the rules field. And as you see here, you can actually define more than one rule. So this policy can have multiple rules, one, for example, to validate the resource, and another rule to mutate it, and etc. So for the sake of this example, this policy match pods, and it uses the validate rule. And inside the validate rule, you write the validation logic under the patron field. And as you see here, under the labels, we require the team label to be exist in the pods. Okay, and what if the pod doesn't have the team label? What happens? So Kyverno can either reject the API request because the pod violates the policy, or we can allow the API request, but in that case, Kyverno will generate warnings to the user so that he knows that the pod violates the policy. So the failure action field is responsible to specify the behavior or the action the Kyverno engine needs to take. So if it is set to enforce, this means that Kyverno will reject the API request because the pod doesn't have the team label. And if the failure action is set to audit, this means that the API request will be accepted, even though the pod violates the policy. So this is yeah, so at the end, you can, if the failure action is set to audit, you can view policy reports that mentions that the pod violates the policy and it's not compatible with the defined policy. Okay. As you see here, this is the policy report that you can get. So in the policy report, we have a section for the results. And as you know, we can have multiple policies that match the pods. So the results section shows all the results for all the policies that match this pod. So we have here the policy name, and we have the resource, and we also have the result. The result, in case the pod doesn't violate the policy, then the result would be pass, and of course we have the rule name. Also, we have the mutation rule. So let's say, for example, that you need to mutate the resource to add the team label. So in that case, you can have a cluster policy, and under the rules, you will specify the mutate rule, and using the patch strategic merge approach, you can add the team label. And this anchor means that if the team label doesn't exist, then we will mutate the pod and add the team label and set it to Bravo. Otherwise, if the team label already exists in the pod, then there will be no mutation at all. Okay. Also, the other type of rule is the generate resources. So let's say, as I mentioned earlier, you can have a use case where you need to generate a network policy for each namespace created. So for this specific use case, you can write, you can of course specify the generate rule, and of course it matches namespaces. And this generate rule is used to generate a secret. Okay, and to define the generated resource, you have two approaches. You can clone the resource if it already exists in the cluster. So, for example, you can generate a secret in the namespace, in the new namespace from the API request, and you don't have to define the secret itself. You can just copy the secret that already exists in the default namespace, and of course you specify its name, and then you are just creating a copy of the existing secret to the new namespace. This is one way of doing that. The other way is to, yeah, we can show it quickly. So the other way is to just specify the data field under the generate rule, and under the data field you will specify the whole manifest or the generated resource. As specified here, we are generating, for example, a config map, and we are specifying the whole data or the whole manifest. Okay. So, and we also have the verify image rules, as I mentioned earlier. So basically, the validate, the mutate, and the generate rules are have always been the core of Kyverno, right? And these rules, what makes it more powerful and flexible. But as Kyverno evolves and new features were added, we started to face some challenges. So, for example, there would be, some cases there might be more than one solutions to fix the same problem. Let's say if we took the validate rules as an example, so you can write your validation logic under the pattern field, as shown earlier in one of the examples, and you can have you can also specify some conditions under the deny rule. So in the validate.deny subrule, there is a possibility to specify some conditions, and if one of these conditions met, I mean if one of these conditions are evaluated to true, then the resource will be blocked. So this is another way of defining a validation logic. And we also have the pod security subrules. As you see here, you can define a validate.pod security subrule to apply the pod security standards. In this example, we are making sure that all the pods meet the baseline profile. So this is another way of doing validation checks. And we also have the validate.cell subrule in case you want to write cell expressions to do the validation part. And finally, you can use assertion trees to write the same validation logic. So as you see, we can have different solutions to fix the same problem. And sometimes it becomes very hard to decide which solution is better. And in some cases, you might find it difficult to understand or to figure out which fields or which configurations you need for your rule type. For example, the validation failure action here is used with the validate rules, right? Because it controls the behavior of how Kyverno engine will react if the pod violates the policy, if the resource violates the policy, right? So this field, the validation failure action, doesn't make sense to the generate rules, for example, right? So it doesn't have any effect when it is used with the generate rules, but it's really uh, um, an effective field with the validation rules, right? So we figured out that those challenges, uh, these are might be a challenge because at the end we introduce one policy type that does everything: validation, mutation, generation, and all the features or all Kyverno capabilities. And at Kyverno, we have always believed that it's really important to to simplify the process of writing a policy. And so the policies should be easy to write and easy to understand. That's why we used the YAML language to write Kyverno policies, because it's familiar to Kubernetes users, right? So now, as Kyverno evolves, it has been very difficult to manage a lot of things because there are a lot of features, and we find out that we need a more consistent and a focused way of writing a policy. And at the same time, uh, the cell language is introduced in Kubernetes. So it was gaining a momentum in Kubernetes as it is used in CRD validations. And as some of you know, Kubernetes introduces admission policies, which are the validating admission policies and the mutating admission policies. And both policies makes use of the cell language. And the cell language becomes more powerful and easy to use and easy to understand. So we decided to do that change. And instead of providing one policy type that does everything, we are introducing new policy types. And all these new policy types makes use of cell language. And also it helped us to extend the functionality to not just apply those policies in a Kubernetes environment, but we can also apply them to any JSON payload. So now Charlewar will walk through these new policy types and introduce us to these new powerful policies.
Okay, thank you, Mariam. So yeah, in the next part of the stream, we're going to look at how we can define validating policy, how we can use it, how we can make similar things that we can do with Kyverno. So maybe if you can share my screen, Iris, thank you. Uh, so let's start first with validating policies. We will look at image validating policies after that. And we can start by looking at the structure of validating policy. Oops, no, okay. So a validating policy has a failure policy, which is fail or ignore. And this determines what the API server will do in case of a failure happening, evaluating the policy. So I don't know if for whatever reason the network is not available and something bad happens. If the failure policy is set to ignore, the API server will let the resource request happen. If the failure policy is set to fail, the API server will just deny the resource request. We have another element called validate actions. It can be a combination of deny, warn, or audit. And of course, deny will reject the request if something goes, if the validation rules are violated. If we set it to warn, for example, the request will be accepted, but a warning will be generated and the violation will be tracked in a policy report. We have an evaluation field, which is this time specific to Kubernetes, where we can say that we want to perform background scanning or validate the resource at admission time. We have an Autogen section to determine how the policy will be processed internally. There's a feature in Kyverno that can create synthetic policies for higher level controllers. Like you can define a policy for pods, and Kyverno will automatically create the equivalent policy for deployments, stateful set, cron jobs, and so on. Basically, all pod controllers that can create pods. So if your deployment is valid against the policy, it's probably the case that the pods the deployment will create will be valid too. We have a match constraints section which determines the resources that apply to the policy. You can also exclude resources. You can use a namespace selector, an object selector. So that's essentially the same thing you have in validating admission policies and webhook configurations. And if that's not enough, there's a match conditions section. This time it's based on CEL. So you can have a programmatic way to determine if the resource applies to the policy. So in this case, for example, if the resource has no labels and no prod label, and that the prod label is not equal to true, the API server will consider that the resource being admitted doesn't apply to the policy, and then it will not evaluate the policy for this resource. So that's really a way to program the API server and let it know that you want this resource or to be validated against the policy or not. And finally, you have the validations field. This validations field contains all the logic to validate the resource being admitted. So in this example, this is a policy that applies to pods, and it detects the privilege escalation in the containers, and if container has a privilege escalation set to true, it will be rejected. So that's what we have here, the object.spec.containers.all. It will loop through all containers, and if a container has the security context configured and the security context dot allow privilege escalation is set, and that it's not equal to false, it will fail the policy with the message privilege escalation is disallowed, and the field spec containers security context dot allow privilege escalation must be set to false. So that's the very simple structure of a validating policy. It's very similar to validating admission policies in Kubernetes, at least in recent versions of Kubernetes. A few differences is that we don't support params and we don't need validating admission policy binding. So the whole logic is a lot simpler, and maintaining a policy is a lot simpler too. We can look at a more complex example for those who know Kyverno from before 1.14. Kyverno had the possibility to define a context in policies. So you could, for example, reference a config map or a secret in a policy, and Kyverno would automatically load this config map or this secret and provide it to the policy. So this was something we wanted to support as well. And we have that in this example. Something we didn't see in the first example, this one didn't use any variables, but just like validating admission policies, validating policies can define variables. And that's the case here. We have one variable with the name CM, and this variable will be initialized with resource.get, which is a Kyverno-specific extension on top of CEL, the CEL language. So we have a lib that can fetch resources from the underlying cluster. Of course, you have to give it the API version, the resource, a namespace, and the name. In case of cluster-wide resource, you don't have to provide a namespace, but config maps are per namespace, so you have to provide the namespace. In this case, the namespace will be fetched from the object being admitted, and the name of the policy is policy-cm. So if everything goes well, this variable will be initialized with the content of the config map in the cluster in the requested namespace. And then from that, we can define another environment, another variable. This time, the name of the variable is environment. And we are going to compute this variable from a different various elements. So some data comes from the object being admitted, and some information come from the variables.cm.data.env, which is the variables we created here. So basically, this is the config map we loaded just previously. And then we can reuse those variables in the validations expressions. So in this case, it will just verify that variables.environment is equal to true. And the message is deployment labels must be and equals prod. And that's what we are checking here. Then it gives us a Boolean in return. So now we have a basic overview of what a validating policy looks like. We can test that. So for that, I created a small cluster locally. So I used Kin to create a local cluster. It has one node for control plane and 3 worker nodes. I installed Kyverno from the Helm chart. So I have Kyverno pods running. And the first demo we can do is, let's clean everything before to make sure it hopefully works. And then we're going to first apply a policy. We will apply a config map, and then we will test a couple of things with this policy. So what this policy does is the same as the second one we saw in this in the first presentation. So it's just going to fetch the config map called policy-cm and check that what we have in the config map matches the deployment labels. In the config map, we will just define env and we will set the value to prod. So every deployment with an env label will be tested against what we have in the config map. So in this case, it will be prod. So this one should be rejected because env is not prod, it's testing. But this one should be accepted. So let's try that. The first thing to do is to, of course, apply the policy. Ow. Okay. So we apply the policy. Then we can try to apply the deployment at this point, but of course, failed to get resource config maps policy-cm. It was not found. So now we will apply the config map. We can try with the non-prod deployment, and this should be rejected. So the admission webhook denied the request and telling us that deployment labels must be env equals prod. That's the message we have here. And finally, this time, deploying a prod deployment, so with the correct label, works as expected. So the deployment was created, and we can check that pods are running, and they are running. So that's the way context works. We have different libraries for validating policies. So we extended the CEL language with the resource library, which can get, list, and post resources. So you can also create resources using this library. We have an HTTP library. So with this, you can call any endpoint external service. You can also call internal services, but it allows you to, I don't know, call any API from inside the policy. We have a user library that is mostly used to parse service accounts. So you often have request.userinfo.username in your admission request. You can use that to decode the service account. Then you can check the name, the namespace, and use the returned service account to check various things. We have an image library. This allows fetching data from decoding an image into a structure and also validating those structures. And we have an image data library. This one can call into OCI registry and return payloads from those registries. So for example, if you use image data.get nginx with a specific version, you can then after access the manifest and the media type, and you will be able to work with that. You can inspect the layers and so on. Of course, all those external calls will add latency to the policy execution. So there's probably a trade-off, but nothing prevents you to call into the OCI registry and manipulate the result. And finally, we have a global context library. Global context is a sort of cache maintained internally by Kyverno. It uses another CRD, which is the global context entry. And using that, you can configure the cache that Kyverno maintains and provides to the policy evaluation logic. So if you create a global context entry, for example, that lists deployments in a specific namespace, you have to provide a refresh interval. But based on that, Kyverno will maintain a cache with different entries based on the name. And then you can access this cache in the policy using the global context.get function. And this will give you back the cache entry. So in the end, those new policy types have access to the same elements that previous policies, so policy and cluster policy. It's implemented quite differently because validating admission policies define variables, and it made complete sense to use the same logic and just to extend the CEL language. So now, if we look back at the demos, we can now look at a very specific feature of Kyverno, and I was talking about Autogen, and this time we are going to demonstrate just that. So let's take this policy. We have a policy defined for pod, and this policy will use the metadata from the different container images, and it will check that all images comes from ghcr.io. And if it's not the case, it will be rejected. So the important part here is that we are working with pods in the policy. So we can first start by applying the policy, and then we're going to create deployments. So remember that the policy was created for pods, and now we are going to create deployments, which is not pod. So if we take the bad pod, the bad deployment, and check that, this time, the too many requests. Oh, it looks like we are hitting the rate limit, so no luck. Anyway, it still demonstrates what happened. Actually, the policy was defined for pods, and we are creating a deployment, but Kyverno was able to create an equivalent policy for deployments because it knows that in a deployment there is a pod spec, and then it can extract the pod spec from the deployment directly and apply the policy on it. Doing this, we can not only validate pods, but we can validate deployments, we can validate stateful set, we can validate all higher level controllers. and make sure that not only pods are validated, but if an invalid deployment is created, it will be rejected, not only the pods that the deployment creates, but the deployment itself would be considered invalid. So I can try to apply the good pod, but if we are hitting it worked. So maybe, okay, so it works, but just for good pod. So yeah, we are hitting the rate limit, and unfortunately it doesn't work. But you get the idea. You define it for pods, and then Kyverno makes all the work to create higher level policies. So in the end, all this is to just accept or reject the policy, accept or reject a resource. Of course, it's not just black or white. Sometimes you want to accept a resource even if it violates some rules. And eventually you want to track the violations in report to eventually fix that later. So that's what we're gonna do here. Instead of denying the resource when the validation fails, we are just going to return a warning and then audit the different results. If we just change the deny to warn in the policy definition, so this time it's not going to reject the resource. The resource will be created. Then we can okay, let's try with too bad. Okay. Okay, maybe we can use another policy for that. Let's take this one. It should work the same, so no worries. So this time we have a policy that checks that that the labels are set correctly based on what we had in the config map. So after a while, we can see that we have a report generated for this resource. So this is for the positive deployment. We have a few stats, 1 passed and 0 fails. And if we look at the report, so we have a policy report from the policy working group. This is a CRD that is not specific to Kyverno, but Kyverno uses it. And we have check deployment labels, which is the name of the policy. The result is passed, so this policy passed. And yeah, we have a timestamp and we have a source. So in this case, the source is a Kyverno validating policy. Of course, if we set the validation actions to 1, some resource will be accepted, even if they violate the policy, and then instead of pass, we will have fail in the result. So yeah, this demo is almost done. The last thing is if you don't have a cluster and want to validate a resource against a policy, you can use the CLI. And in this case, we are going to take one of the policies we already used in this live stream, which validates a label on a resource and a deployment. So this one has another label and not prod. And this time we are just going to invoke the kubectl -kyverno CLI. And we can see that this time the deployment failed the check deployment labels policy. If we put prod here, we should have another outcome. Okay, so this time it passed. So what we demonstrated here is how a validating policy can access resources and other information, image metadata, and other things. How we can use policies to validate resources, how we can use auto-generated policies for higher level pod controllers, how policies can participate in reporting, and how to use those policies in the CLI, potentially in a CI pipeline or something like this. The last thing we have is we can use the Kyverno playground. So the Kyverno playground already supports Kyverno 1.14. And in this example, we are going to check the image registry. So we are going to verify that all images are coming from ghcr.io, and we have a good deployment and a bad deployment. Hopefully, we are not going to hit the rate limit, so no, not this time. And then the good deployment passes the policy, and the bad deployment violates the policy. So just because the bad deployment has an image coming from Docker Hub, and the good deployment has an image coming from ghcr.io. And this one, for example, checks that the deployment is in a namespace that is allowed. So again, we have a bad deployment and a good deployment. And this time we can see that the deployment is not in the allowed list, whereas the first one is. So in the list we have dev, test, and stage. And this one is the bad deployment tries to deploy in the prod namespace. Of course, the good deployment tries to deploy in the test namespace. And that's it. The other policy type coming with Kyverno 1.14 is image validating policy. This time it's used to validate images. So we have something very similar. We have Autogen support. We have webhook configuration, so we can increase the timeout. We have failure policy, validation actions, and so on. One difference is that we now have a match image references. This policy will apply to some images, but not to others. We have an attestors and attestation fields that are used to verify the signature the image signatures. In this case, we support notary and cosign. And we have validations that are used to verify image signatures, verify attestations, and things like this. So we can have a quick demo. This is, I think we are a bit late on time, but we should be good. I will delete all validating policies first. Eventually deployments, if we have. Okay, we don't have. In this case, we are going to apply we are going to apply an image validating policy, this one. So it's denoted by the image validating policy kind. And this one will apply to all images starting with ghcr.io. And we will verify that those images are signed by notary with a certificate added here. And then we will first try to create a pod with an image having a tag signed by someone else. And of course, we signed this image with another certificate, not the one present in this policy. So if we try to apply that, and we didn't hit the rate limit, this time the policy rejected the resource, and it tells us that the policy failed to verify the image with the notary certificate. And if we try to apply the pod that was signed by the right certificate, this time it should work and be accepted. So this was accepted because this image was actually signed with the correct certificate, at least with the same certificate we have in the policy. This certificate could come from a secret or something else. We would just have to fetch the secret in the variable. So we would have a resource.get with the expected secret. And this also works in the CLI. And this also works in the playground. So we have a couple of samples in the playground where you can use to play with image validating policies. So this one is going to do the same thing. It will verify that the image is signed with the correct certificate, and it passes. This one is going to attestation signatures, so verify image signatures. So this one is going to verify attestation signatures. This is a bit different, but it will use the same thing. The certificate passed into the policy. And the last one is going to map payload bomb format. I don't know exactly what this one is going to do. It's going to verify that the SBOM has been generated with Cyclone DX. And I guess if I put CX here, this time it fails, telling me that the SBOM is not a Cyclone DX one. And I think I covered everything. At least I covered validating policy and image validating policies. Um, now, of course, it's not the end. This is what we did and introduced in Kyverno 1.14. We have some future work. We are going to work on other policy types. We want to support mutating policies. We want to support generating policies and cleanup policies. So yeah, this is what we didn't have time to implement all that in 1.14, but it will be a hot topic for 1.15. We also want to work on a migration tool to help migrating from the old policy format to the new policy format. We want to deprecate Kyverno JSON because now Kyverno JSON has all features integrated in Kyverno directly. So Kyverno JSON doesn't really make sense anymore. You can do the same with just Kyverno. And probably other things we didn't think about now, but doing all this, and there's also one aspect that we didn't talk about, unfortunately, the the support for CEL in Kubernetes natively makes the API server programmable. So this is really something we should leverage more and more. We are actively participating and contributing to Kubernetes upstream to make part of what we did for Kyverno available directly in validating admission policies. We recently contributed the image library, and chances are that this library will be directly available in Kubernetes, and you will be able to do the same with Kubernetes native libs. And as it doesn't involve any network call, being able to program the API server directly is really a good thing. So yeah, that's another aspect we want to leverage as much as possible. So yes, sorry for being too long.
No problem. Thank you for the presentation. We have a bunch of questions, actually.
Okay.
I've put the first one on the screen. Is there any chance that these files or the repo you were demoing will be available so people can play along at home?
Of course, I don't know how to communicate that, but most of those policies are taken from our KubeCon talk. So if you look at the KubeCon session slides from Frank and Vishal, you will find all the links to reproduce the same things in the playground. And then, of course, you can just copy paste the manifests, use that in a local cluster or in the CLI. But there's nothing private. You just try to find the session on the KubeCon website, and you should have access to the slides, and all the material is in the slide.
Thank you. We don't have so much time, so we have quite a lot of questions, actually, so I'm gonna go through them quick. So hopefully we can give some quick answers. The first one is there a way to use Kyverno to evaluate that external secrets follow our least privileged naming conventions or IAM roles?
Well, let's privilege. I don't have a lot of experience with external secrets, but I guess that as long as that's something you can program in CEL, you could probably do it, even if you need to access another resource for that, or if it's just validating a name, there's definitely no problem doing it. If that's something more complex, I mean, the limit is what CEL can do. In any case, you could even create an external service and call into this service to perform the complex validation logic, and it could return yes or no.
Perfect. And the next one, you can read them actually. What are the key selling points of Kyverno?
What the key
Or
selling points of Kyverno? The key selling points are probably the flexibility. And today, the reporting, all the tooling in the Kyverno ecosystem, we didn't talk about all the different projects, but there is a policy reporter that brings alerting and dashboarding around policy violations. We have Kyverno JSON, but today is going to be deprecated because we just merged everything in Kyverno. We have an Envoy plugin so that you can create Envoy policies on top of Istio or other service meshes. So this is really a vast ecosystem and lots of tooling exist. I mean, there are other solutions, but Kyverno is probably the most modern one. So I would recommend it. Yeah. Anyway, governance is a good thing to have anyway.
and on the next one, are Kubernetes API calls supported in validating policies variables?
Yeah, definitely. You can call any Kubernetes API or any service. You can format everything because it's just CEL. So you can manipulate the data, and you can even create a random URL if you want, but you can create an URL from the object being admitted and so on. It was planned for today. It will probably be tomorrow because it starts being late now, but it's for tomorrow, today or tomorrow, but I would say tomorrow.
It's our fault. Sorry, we kept him busy with this live stream.
Okay.
And the very last question: should
Yeah,
we expect? Yeah.
yeah. So potentially yes. One of the challenges maintaining an open source project is the time it takes to do so. And now the more APIs we have, the more work we have to maintain them. So it makes sense that new policy types will replace old policy types. So it's not going to happen tomorrow. We need some tooling to allow smooth migration from old policies to new policies. But yeah, at some point, not tomorrow, but in, I don't know, 3, 4, 5, or maybe 10 versions, we will probably deprecate them in favor of the new policy types.
Okay, this is the very last one. It's not a question, but it's a statement. Kyverno also integrates with EKS ingress controllers with load balancers. And thank you, Amit, for thanking us and for watching.
Yeah, thanks a lot.
We are just slightly over time, but it's okay. We managed to answer all the questions. Thank you, everyone, for being here with us. And thank you to both our presenters. As you noticed, Mariam had to leave a bit earlier. But yeah, we managed to get through all the questions. And thank you again for being here with us.
Thank you, Iris.